Hello everyone. This is the first worksheet on chapter 12, which is about inferences for one population proportions. Now this particular problem we've already worked during our lecture PowerPoint, so you may want to look it up also on the lecture PowerPoint for chapter 12, but I'm going to work through this one more time. All right, but I'm going to move fast, all right, because you've already seen this problem work before, hopefully. The problem is about playing hooky from work. So a poll was conducted on 1010. So some words are missing. We'll fill that in. A poll was conducted on 1010 randomly selected US employees. The employees sampled were asked whether they play hooky, that is, call in sick at least once a year simply to relax at home. 202 responded yes. Use this data to find a 95% confidence interval for the proportion P of all US employees who play hooky. So this particular problem is about confidence interval, about finding confidence interval for proportions. Now, recall two things on chapter 12. The first thing is we don't talk about means here. Instead, we talk about proportions. All right. So let me pull up my pen quickly. We talk about proportions in this chapter because the chapter is on population proportions. So proportions, percentages are all the same thing. So sometimes you will see the data given to you in percentages. You can always convert that to proportions by dividing by 100. But let's try to extract some of the data here. In proportions, we need X, which represents, so let me write that down here. All right, so if you recall, sample proportions is denoted by the symbol P with a hat on top of it. It's called P hat. And the formula for P hat is X divided by N. N represents the total sample size. It represents the sample size, whereas X represents the number of people or number of items or entities that meet a specified attribute. All right. So number of people who said yes to your question to the attribute that you were looking for. All right. So in this example, the specified attribute is if somebody has played hooky in the last at least once a year. Right? If somebody has called in sick at least once a year, that's the specific criteria, the specified criteria we are looking for. And it seems out of a total of 1010 people that were polled, 202 responded yes. That means the 202 is our X value. They have met the criteria that they have played hooky at least once a year. So we are going to say X is going to be 202 and N is the number of not respondents, the number of people who were surveyed. All right. So sample size is what N is. X means respondents saying yes. Saying yes to your question that you surveyed. So the question is use this data to find a 95% confidence interval. But before we go into finding the confidence interval, we have to determine the proportions, right? So the proportions of success is p hat. It goes by the simple formula p hat equals x divided by n. We know x is 202 and n is 1010. And when you do that calculation, you should come up with a value of 0.20 approximately, and that's our success proportion. It's also called the success proportion because it represents the proportion that met your specified criteria. Then part C says calculate the proportion of failures. That means the proportion that did not meet the specified criteria. In other words, the people who did not play hooky or responded they did not play hooky. And that can be found by the formula 1 minus p hat. So 1 minus p hat is 0.20. So if you do 1 minus 0.20, you're going to get 0.80. And that's the failure proportion. It's failure just because this proportion of people that were surveyed did not meet the specified criteria. D says, are the assumptions to conduct a 1 proportion Z interval test met? Yes, it's a simple random sample. All right, it's a simple random sample. And then the next criteria that must be met is that the number of, in other words, the number of successes and the number of failures must be greater or equal to 0. In other words, x and n minus x. X represents the success, not the proportion, but it represents the number of people who fell in that success category, who responded yes to that specified criteria, and n minus x is the number of respondents who did not fall in that success category. So they are all greater or equal to 5. That's the criterion that needed to be met, and it is met, right? 202 respondents out of 1,010 said yes, that was x, which is greater than 5, and n minus x also would be greater than 5. Now it says state the confidence interval. We were asked to find the confidence interval at 95%. So CI is 95%. CL is the decimal version of the 95%, so 0.95. Alpha is 1 minus CL, therefore 0.05. And alpha by 2 is divide your 0.05 by 2, which is 0.025. And then you're going to use your table 2 or your calculators. If you have a graphing calculators, you can find your Z of 0.025 is 1.96. All right, that's Z of alpha by 2. So now that we have Z of alpha by 2, we have to apply this formula to find the confidence interval. So CI would be P hat is 0.2 plus minus 1.96, and then multiplied by square root over P hat is 0.2, and 1 minus P hat we already found here is 0.80. So I'm just going to write 0.80 divided by 1010. So 1010 is our n. And this is division, all right? This slanted line means division. Do not end up multiplying. I've seen that happen all too frequently, so I just wanted to alert you to that. This is division. So confidence interval will be 0.2 plus minus 1. Well, when you do this calculation, which is the margin of error calculation, whatever you add and subtract to the point estimate, in this case 0.2, represents your margin of error, correct? So that margin of error value is really 0.024. So your confidence interval, when you add and subtract the margin of error to the proportion to the point estimate of 0.20, you should come up with a value of 0.175 to 0.22, right? So the final step is to interpret the interval. The way you interpret a confidence interval is you start with the percentage confidence interval that you use to find the interval. So we can be 95% confident, 95% confident that the population proportion, or we can just use the wording in the question, all right, that the population proportion of all US employees, or that the proportion of all, and this word is very important because that word all tells us we are talking about the population proportion, all right? So, or you can also write here population proportion, the population, all right, that the population proportion of all US employees who played hooky once a year, or at least once a year, all right, let's make this at least to be more precise, at least once a year, will be contained in the interval, and then just state your interval, 0.175 to 0.22. Now, this is the proportion, but the proportion can be translated into percentage, and we could have written this as the percentage of all US employees who played hooky at least once a year would be contained in the intervals 17.5% to 22%. So you could have also stated this using percentages. However, we'll just keep it as proportions. All right. Now, the next part of the question says, obtain a sample size that will ensure a margin of error of at most 0.01 for a 95% confidence interval. Now, they're asking us to find n, which is the sample size, right? N, the sample size, and there is a formula to find the n, all right, for proportions particularly, and that is 0.25, which is a constant value, 0.25 times z of alpha by 2 divided by e, which is the margin of error squared. All right. Now, we could also use another formula, which is n equals guesstimated proportion. So p hat sub g. All right, p hat sub g times 1 minus p hat sub g times z of alpha by 2 divided by e whole square. Now, if the question does not ask you to use the guesstimated proportion, then do not use this formula, all right? Because if you have to find it using the guesstimated proportion, you should be given what the guesstimated proportion is. Here, they haven't given us the guesstimated proportion. All right, so when they have not given us the guesstimated proportion, we have to use the constant one, which is 0.25. In other words, the 0.25 proportion, it uses a proportion value of 0.5. All right, so what I'm going to do is I'm going to erase the guesstimated formula, the guesstimated proportion formula, and just use the one which works with a constant value for the proportion. All right, so let me just write it down. 0 equals 0.25 times, now z of alpha by 2. What is alpha by 2? It says here 95% confidence interval. That makes the alpha value 0.05, right? And alpha by 2 would be 0.025. Okay, so z of 0.025, just a second, let me erase this. (0.025) over, now E is a margin of error, correct? This is what E is. And what is E? 0.01. It's given to us. So 0.01. And then there is a square. We need to square that. So let's complete the calculation. We have 0.25. Z of 0.025 is 1.96 over 0.01 squared, which gives us an expression which is 0.25. Now 1.96 divided by 0.01 is really 196 squared. All right, 196 squared, which will calculate to 9,604. So N will be roughly 9,604. So we will need a sample size of 9,604 to ensure a margin of error of at most 0.01 for a 95% confidence interval. This is how you work it out. Now this formula is there on the formula sheet for chapter 12. So you just need to look it up, and if they have not given you haven't given you a guesstimated proportion, use the one with the constant value of 0.25. Okay, so I'm going to skip these two questions and put up another recording and solve this one as well. Now, this is also a question on finding confidence interval. So I'll put up a recording on this one as well. Hello, everyone. This is another question from worksheet 1 of chapter 12. The second question here says, from the just a second, let me pull up my pointer here. From the US Census Bureau document and an article in Time magazine, it was found that in 1963, 83% of American women between the ages of 25 and 54 were married, compared to 64.6% in 2010. For 2010, for the year 2010, identify the population. So let's go back and reread this and try to understand what the problem is about. It says here that it seems they are studying the age of American women when they were married, right? So in 1963, it seems 83% of American women between the ages of 25 and 54 were married, compared to 64.6% in 2010. So they have given us the data here in percentage, not in proportion. Remember, this is a chapter on proportions, but the data in this question is given to us in percentage. But keep in mind that proportion and percentages can be translated back and forth into each other. Okay, so first question says, for 2010, identify the population. So for 2010, the population would be all American women, all right, all American women in the age or between the ages 25 and 54. All right. So of all American women in this age group, we want to know what proportion or what percentage were married. Apparently in 2010 it was just 64.6% compared to the 83% in 1963. But the population is all American women. All right. It's not all American married women. Okay, that would be a wrong answer, or wouldn't be an appropriate answer, because of all American women, we are trying to find what proportion were married. Okay, but the population would be all American women. Identify the specified attribute. Now, in this case, the specified attribute would be being married. That's what we are trying to study. What proportion were in the status of married. Part C says, under what circumstances is the proportion 0.646 a population proportion? Again, now this time they have given us the data in proportion form, which is a translation of the 64.6% data, or the 64.6% of 2010 data, of the 2010 data. All right, so we can say that the 0.646 can be a population proportion, if it is based on the maybe the birth, death, marriage, or divorce records of all women in the US aged in the age group 25 to 54. All right. And then for D, it says, under what circumstances is the proportion 0.646 a sample proportion? It would be a sample proportion if this proportion is based on a sample of women of ages 24 to 54 in the US. So we could say it would be considered a sample proportion. So you can write that, and then, all right, I'm going to put in dashes here. If the proportion was based on a sample, of all women in the US in the age group 25 to 54. That's all right? This question does not ask us to find the confidence interval or any such thing. Let's work on this question here, which is number 3 of the first worksheet in chapter 12. This is a straightforward problem. It's not application based. They've given us the values of X and N, and they're asking us to find the 95% confidence level. It says here, below are provided the number of successes and the sample size for a simple random sample from a population. X equals 8, N equals 40, and 95% confidence level is what we need to find. The first part says determine the sample proportion. So to find the sample proportion, the formula again is P hat equals X divided by N. X is given to us as 8, N is given to us as 40, which gives us a sample proportion of 0.20, which represents the success proportion. And then if you want to find 1 minus P hat, because we will need to know 1 minus P hat for the confidence, when we find the confidence interval and use the formula, we will need to plug in a value for 1 minus P hat. Just take the P hat value and subtract from 1, which is 1 minus 0.20, which is going to be 0.80, and that's going to represent our failure proportion. Decide whether using the 1 proportion Z interval is appropriate or not. Now, it better be a simple random sample, which is given here, the simple random sample. And the other criterion that needs to be met is that X and N minus X must be greater or equal to 5. X is 8, which is greater or equal to 5, and N minus X, which is 40 minus 8 is 32, is also greater than 5. So both conditions are met. Both conditions are met. So we can go ahead and both conditions met. So use the Z interval procedure. The Z interval procedure is appropriate for us to use. Okay, so now we have to find the confidence interval. Again, all questions in chapter 12 will use the Z distribution. All right, so determine alpha. We are using, or we are finding, a 95% confidence interval that gives us an alpha value of 0.05, and our alpha by 2 is 0.025. Z of alpha by 2, which is Z of 0.025, is 1.96. We can now determine the confidence interval, or calculate the confidence interval for P by using the formula. So here is our formula. P hat plus minus Z of alpha by 2 times square root over P hat times 1 minus P hat. That's where we need to know the value of 1 minus P hat divided by N. All right, not N sub 1, N. So P hat is 0.20 plus minus Z of alpha by 2. We found is 1.96. Square root over P hat again is 0.20 times 0.80 divided by N is, again, this is a division, so I'm going to write the 40 a little bit below the line. So 0.20 plus minus 1.96. 1.96, and this whole calculation, the radical, everything under the radical calculates to 0.20 times 0.80 is 0.16 divided by 40. When you take the square root of it, you should come up with a value of 0.063. So you have to complete this multiplication first before you can go and add or subtract it to the proportion, to the sample proportion. So we'll end up with 0.20 plus minus 0.124, which is going to give us a confidence interval. So here all the way we are finding our confidence interval. So our confidence interval is going to be 0.076 to 0.324. So that's our confidence interval. If you translate this into percentage, it's going to be 7.6% to 32.4%, but leave it in proportion form unless they specifically ask you to write it in percentage form. All right. So this is how you find your confidence interval. The next part of the question says find the margin of error for the estimate of P and express the confidence interval in terms of the sample proportion and the margin of error. So the margin of error we already calculated above. Here is margin of error is 0.124. Okay, so you can just write it. You don't have to rework it again if you have the value up above in the parts in the section above. Okay, and then over here it says below are provided the margin of error and a confidence level. Obtain a sample size that will ensure a margin of error of at most the one specified, which is margin of error 0.01 and confidence level 95%. So here they're asking you to find a sample size. So N. So N, the formula says N equals 0.25 multiplied by Z of alpha by 2 divided by E squared, correct? So 0.25 times Z of alpha by 2 is how much? Z, what is the confidence level? 95%. So that makes alpha equal 0.05. Alpha by 2 will also be 0.025. So it will be Z of 0.025 divided by E is given to us as 0.01. All right, squared. So we still have to keep going because we don't have a value for Z of 0.025. It's 1.96. I just have it memorized, but go to your table and find it if you don't remember what it is. Or you can also use your graphing calculators to find it. So we will have N equals 0.25 times 1.96 divided by 0.01 is 196. All right, so 196, then square it, and you will get a value of N, which is 9604. 9604. All right, so that's your final answer for this particular problem of finding the sample size.